I'm gonna go ahead and record. All right, let's go back and look at what we talked about yesterday. Linear equations have an x power of 1 here. So like if I were saying y equals x, then that would be linear. But in this case, quadratic functions have an x squared term. So it's a y equals x squared. Well, there's more to it than that. And we'll get into the details, which is this right here in just a minute. We're supposed to be focusing in on vertex form today. We'll see how things go. But we'll learn what that is. But basically what it is just a format of this to help you figure out what the vertex of your graph is, whether it's the minimum or the maximum of your graph. In this case, the vertex was 0, 0, and we found that right here, where we said it was like the line of symmetry, but if you go this direction or this direction, you're going to have an equal distance from the line of symmetry. You're going to have this similar number here as you go back. So vertex is 0, 0, and your axis of symmetry was x equals 0. We talked about this, and I told you yesterday that I would help you try to learn what this is. All right, so I want you to understand in math terminology, you got something that's called, well, you got closed and open. Okay, so that's the focus that we're going to look at here. This is like an open-ended. Think of it like this. It's like you've got a circle at the end and a circle at the end. All right, like that, like it's open on the graph on the ends. But in this case, it's open on one side and closed on the other. And what that means is it's definitely 0 is where it begins at. The range, like right here, this range definitely begins at 0. But infinity is kind of an open-ended idea. So anytime you see infinity, you're never going to have a box like that here. It's never going to be like definitely infinity. Well, infinity is no more than just a very, very large number. There's nothing special about infinity. It's just that it's so big that there's no point in writing down how big that number is. You just have to give it a value, kind of like we do with the I value. It's imaginary, so you just kind of have to give a symbol for it. Okay. All right. So let's look at this. We're going to talk about vertex form of a parabola, and this is I think I'm on page, if I remember right. Let me see what page this is. 17. I think on that Microsoft Teams file, you had to go under like Algebra 2, and then you have to go under lecture /HW or something like that, and you click on that. So there's an Algebra 2 video file, and then the lecture information is under section 5. So if you go to section 5 and click on lecture HW, the pages that I wanted you to print off were pages 16 through, I can't remember what I said, like 20 or something yesterday. But now we're on page 17, which is really equivalent to this. So 5.3208. All right, so let's read what it says here. The graph of the quadratic function is a parabola. A parabola is basically just like a bowl shape, I guess you could think like that. So the function f of x is equal to x squared. And now remember, f of x is the same thing as saying y. Okay, so anytime you see f of x or g of x, or if you see something that looks like this, g of t equals s or something like that, you could just put y equals, whatever. These variables can be represented by y and x. Okay, well, that actually would be, that actually should be. Anyway, we'll get into that later. Okay, so it's the parent graph function. We talked about parent functions for like one day, I think, in Algebra 2, maybe, and when we were in the classroom. And it says we can derive all other parabolas from this function. Well, what is the parent function? Bam, that's the parent function right there. okay? So now vertex form of this parabola has that in it. It's got y equals x squared there, but they've got a bunch of other crud here, which is indicative of parts of the graph that you're going to need to know. Like in this case, vertex is equal to hk. hk. Now remember, h has a minus in front of it in this form, so you got to be careful when you're going to pick your h that you don't pull that minus with it, okay? All right, so now remember the vertex of the last graph that we did was 0, 0, right? So if you put 0 here and 0 there, then you'd be left with nothing but x, okay? Now we haven't talked about A. A tells us whether this bowl shape opens up or opens down. If it's positive, it opens up. If it's negative, it opens down. So if your A value right here is positive, it does this. If your A value right here is negative, it opens down like that. So that's basically what this means, the less than and greater than stuff. The larger the absolute value of A is, the thinner the parabola is. So in other words, it could be really skinny depending on the value of A. So you could still open upward or downward, but A being like a real thin number, like 1/3 or 1/7, it could be like really skinny here. But if it's like 5, then like a much bigger number, it's going to be wide. Okay. So let's go down here. Now we got to keep this in our minds. We're going to lock this in our brains because this is a form that we can use on the ACT, vertex form, okay, of a quadratic. Now it's not easy to remember like ABC, but it is easy to remember if you can memorize HK being the H comma K being the vertex. You can, that's part of the equation there, okay? All right, so now we've got, let's go down here and graph this parabola here, and we're going to write it out, the actual form. I want you to get practice writing out this format here. Okay, so in this case, I want to remember I told you not to be careful not to pull that minus with the H. Well, that minus in that 1, yeah, it's always sticky, right? But if you cover up the minus in front of the H is actually going to be 1 here, and the K is going to be 1. So your vertex already before we start is going to be 1, 1. Okay, and so our vertex is going to be right here. Now here's the deal. Is this going to open downward or is it going to open upward? All right, if we go over here and look at A, it says make sure the parabola is in the form blah, 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 and it is. And then plot the vertex HK. Well, we just found HK was 1, 1. All right, does the parabola open up or down? Well, if you look at A is equal to 2. Now, not only is this gonna open upward, we're gonna open upward, but it's going to be a pretty wide graph. Like it's going to be not like this, it's going to be more like spread out, okay? Now, so the axis of symmetry is the vertical line x equals h. Now, let's go back up here. Remember our axis of symmetry on the last one was x equals 0. Well, our h was 0 earlier, okay? Now, our axis of symmetry is going to be x equals where h is. Now, it should make sense that your axis of symmetry and your vertex are always going to match up. Your axis of symmetry and your vertex are always going to be on the same place. So like in this case right here, I already know my vertex is there. So you know the axis of symmetry. I'm going to put a dotted line like this, okay? All the way down. So x equals 1 is the axis of symmetry. And so what that means is it's going to open upward and it's going to open this way and spread out like that. It's not going to come over to 0 and spread out that way. It's going to shift over 1 and go that way, okay? All right, so let's look at, I'm looking at some things right real quick. I want you to get in the habit of making a t-table, all right? So I'm going to come over here to the right and write out a little t-table chart. So let's go ahead and write our formula. We're going to scrunch it in pretty tight here because there's not much room. All right. there's my formula that they gave me earlier up here. I'm just rewriting it down so I can make a t-table out here. So I'm going to go, we don't have a lot of room, so we're going to have to be very careful about this. All right. So first thing I want to talk about is the values of x that you can choose here to find your y value. First off, you need to understand that if 1 is my axis of symmetry, you kind of need to put that in the middle of the numbers that you choose. And so in this case right here, you remember we just talked about 1 being the center. I mean, no, not the center, the vertex. Well, that's what's going to happen here. So watch when I put this 1 here. So I'm gonna put a 1 right there. So what's 1 take away 1? That would be 0, right? 0 squared is 0. 2 times 0 is 0. And 0 plus 1 is 1. Okay? So that's how this works here. Now you got to think, this is your line of symmetry right down the middle. So if you're smart about this and space out your domain values here in your x range or in your x domain, so evenly, then you only have to figure out 2 more numbers to try to kind of get an idea of what's going on. So in this case, instead of 1, I'm going to go 2 and 3 this way, okay? And then the other way, I'm going to go 1 less than 1, which is 0, and then 1 less than that, which is -1. Okay, so now the easiest way to go, well, I think probably the easiest way to go would be to use the 0, but to stay away from this negative is what I'm trying to get at. So let's stay positive here for just a second and use 2 in the place of x. So x is 2. So we're going to put 2 right here. 2 minus 1 is 1. 1 squared is 1. And then 1 times 2 is 2. 2 plus 1 is 3. Okay? And so what that means is I'm going to go out to 2, go up 1, 2, 3, and put a dot on my graph. Now here's the deal. I don't have to do that again up here. This is going to be a mirror image. So I know automatically that that's going to be 3. Wait a minute. Something's up here. Yeah. Okay, so -0 minus 1. So that would be -1 squared is 1. 1 times 2 is 2. And 2 plus 1 is 3. So yeah, that would work out. All right, so let's go to the next one. Let's go down here to 3. All right, let's put 3 in here. 3 minus 1 is 2. 2 squared is 4. 4 times 2 is 8. And 8 plus 1 is 9. Okay, and so we can go over here to 3 comma 9. Go out to 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Double check that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put my dot right there. Okay. So my graph is going to extend upward like that. And then now if you'll notice here, I can, this is a mirror image. These are equal distance away from the center. So that I can go ahead and assume that that's going to be 9 there. So I'm going to go ahead and graph these other 2 points. And it should be like a mirror reflection across. So you can just think of it like a mirror reflecting across the middle here. And then this one's 2 away from there. So I need to go 2 this way. All right. So if I spread this out, so this goes forever in both directions like that. Now remember, this is not a V. This is more like a U. It's a bowl shape. Okay. Got to be careful about that bottom there, because you don't want to confuse this, especially when you get to a much skinnier graph. It can easily be confused with an absolute value because it's harder to round that out. All right, so let's go down here to we've already it said plot 2 points, but I plotted more than that. On one side of the axis of symmetry, then corresponding symmetrical points on the other side of the AOS. So that's basic. The 2 points that I did were here and here, okay? All right, so Now let's go over and figure out what the domain is. Now the domain is going to be this way. Okay, so imagine just like I was telling one of my students in my class, her her name reminds you of the season fall, like fall leaves falls down, right? So think about this, like if your tree wilted and all the leaves fell down like this, and now this goes forever. So you have leaves falling all the way down here, and then it would all bunch up here on the bottom here. This is what the domain is, okay? So your domain would be basically everything to infinity here and everything to infinity here. So you guessed it, we're going to use the open-ended stuff here. All right. We're going to go from, now the way this is, it looks like this is a coordinate point, but actually it's not. It goes from negative infinity to a positive infinity. This is not a coordinate location like that. This is a stretch of values. All right. So now range, if all you have to do for range is turn it sideways like this, and let's look at the range values. So if this were to, and not, I guess, necessarily fall, but like rise, to the line here. So where would it start? It would start definitely at 1, right? The number 1. And then it goes all the way up to infinity. So that's going to be open-ended over here. So it's going to go from 1 definitely. It's going to go from 1 definitely to positive infinity, somewhere around positive infinity. So that's why there's a box on one end and a rounded area on the other. Okay, so I want to pull that back and let y'all catch up with that, and then I want to try and wrap up 5.3 today, and then we might do a little review on the last couple of lessons that we've done. We might go back to one of those challenge problems or something. All right, so let's go to the next page. See how many pages we've got here. So we've got 1, 2, 3. I want to get through 3 if we can this today, and we're halfway through. So we got to speed this puppy up, right? So let's see how quickly we can do this. Now, if I go too fast for you here, just remember you can always pause the video if you're watching YouTube. Obviously, if you're watching the Zoom right now, you can't pause me. But I want you to see how quickly you should be able to handle something like this, okay? All right, so now I am going to take longer than I actually would because I'm going to work out all the details. If I were doing this personally, I would just get the answer and move on, okay? But I'm going to point out quickly the high points here. All right, obviously A is negative, so it's going to open down, okay, open downward. So A is -2, all right? What's H? Now we got to be careful about this. Whoa, we got a positive there. Positive is really double negative, okay? So if you rewrote this, remember it's supposed to be minus H. Well, this is minus -2, so -2 would be my H. That's tricky right there, okay? And in this case, the same idea. It's a plus -1 there, okay? So if I added a -1, it's the same as -1. So my K would be plus K or -1, okay? So my vertex is going to be -2, -1, okay? Now that was tricky. Very, very tricky. All right, so let's go back and do 1, 2, and then down 1 and put a dot there. That's where my vertex is going to be. Remember, your axis of symmetry or your, well, yeah, you guess you can call it the axis of symmetry. It was going to include the vertex, and in this case, it opens downward. So your graph should look like a frown, okay? Just like that. All right, so let's move over, and it says the axis of symmetry is the vertical line x equals, what was h? H was -2, okay, because it's minus h, minus -2, so -2 is my axis of symmetry. And where is x equal to -2? Right here. And the line that is included in that is this right here. So it has nothing to do with y. It never touches the y-axis ever. So that's why x is not in this equation. All right. So now let's move over and do the next step, which is to plot 2 points on the sides. So we're going to go one away on both sides, here and here and here and here, from the axis of symmetry. So let's be smart about this. Now, let's cut our work in half this time, all right? So I'm going to rewrite the equation. So y equals -2 plus 2 squared minus 1. And we're going to put in one that we're going to go this way because I want to go towards 0. 0 is always easier to put into an equation. Let's see. Let's do -1 and 0. If I do -1 and 0, I can find the dot where it's located on this line, and then I can also find the dot on the opposite side because of the mirror image. All right, let's do -1 first since it's the hardest. All right, -1 plus 2, that's 2 minus 1. 2 minus 1 is 1. 1 squared is 1. And then 1 times -2 is -2. And -2 minus 1 is -3. Wow, that was math gymnastics right there, okay? So let's look at 0 now. We've got 0 plus 2 is 2. 2 squared is 4. 4 times -2 is -8. And then -8 minus 1 is -9, okay? So now I can graph these 2 points, and this stuff really should probably have been in that little box right there, but I'm doing it on the side so you can see what we're doing here. All right, so we've got -1, -3, so it's going to go start from the origin, go -1, and then 1, 2, 3. Dot there. All right. And on the opposite side, your mirror image is going to look like that. So here's your axis of symmetry. It's going to make a U shape like that. Now we're going to go 0, -9, 0, then all the way down to -9, which should be 5, 6, 7, 8, 9, right there. Okay. Now notice that it's 2 away from the axis of symmetry here. So this other dot is going to be 2 away from the axis of symmetry over here. All right. So we're going to round this out. Try and make a bold shape like that. Okay. All right, and it goes forever in both directions downward because of the A value that was negative, okay? That A value changes if that A value was positive, it would have just gone like that, all right? So now we're gonna go to the domain and range here. Let's see what's happening here. So think of it like rising this time instead of falling. So we're gonna start here and we're gonna rise, both sides go forever in both directions. So we've got -infinity to positive infinity for the domain, and they're open-ended because you can't really say a definite infinity value. You could make any number really, or stop at any number. Let's go turn it over this way and let's do the range sideways. Where does it definitely start? It definitely starts at -1, all right? Here's 0, here's -1, there's -2, there's -3. It starts at -1 and it goes forever. Like if all these were to fall onto this line right here, this line would be from -1 definitely to infinity open-ended. So we're going to go from -1 definitely, close box like this, bracket, and then we're going to -infinity this time, so you got to be careful about that. All right. You could see some answers like this on the ACT where they've got these 2 different choices of what your range or domain are, and then you'd have to pick them out. Now you know what they are, what that means. Okay. I'll see if I can find an ACT question that has something similar to that in it later to prove that. All right, let's move on. We got now that took us, 7 minutes? So we've got 2 more pages to do. Can we do it faster this time? All right. So look, I'm not gonna do a lot of talking. I'm just gonna do writing. So just try try to keep up with me on this next one, and let's see what at the end, when I get through, I'll hit the high points, okay? All right, so just kind of keep your eyes peeled to what's going on, and I'm gonna hold off on my chat in just a little bit, all right? All right, I am going to have to speak right here because I did make a mistake right here. If you'll notice, this is minus -3. So positive is minus -3. So H is going to be -3. And just while I'm talking, let's discuss this. This K is 0. It wasn't there, so K has to be 0. So this has to be -3, 0. I could have made a huge mistake right there if I didn't catch that. Okay, in this case right here, 4 times -1/2. This is 3 minus, okay, wait. Yeah, 3 minus 1 is 2. 2 squared is 4. 4 times -1/2. Half of 4 is 2. -1/2 times 4 is -2. Okay, all right. So okay, done. So I want you to look at that. That took me 4 minutes or so, just writing down all the detail here, just kind of hitting the high points here before we wrap up with the last problem. Let's go back and look at this. I'll put this, I know some of y'all are still writing this, but I'm going to go look at this real quick. So A times X minus H all squared plus K. This is called vertex form of a quadratic. Okay, and so the A was -1/2. H in this case was minus -3, so H is -3. There was no K out here, so I had to put +0. And so that means my h and k were going to be -3 and 0. And my a opens downward. It's a -1/2. Now, if you'll notice that this graph is starting to get wider and wider. So I made a mistake earlier. I said 5 would be, actually, if you had like a number 5 instead of -1/2, you would have a very, very skinny graph. Okay. The wider, the smaller that, or closer this number gets to 0, the wider it spreads out. Okay. So the axis of symmetry is x equals h according to this formula. So that's x equals -3, not +3. Be careful. So that's -3 is your axis of symmetry here, and our vertex was on that. Our vertex was -3, 0. Then we came down here and chose two values, one away and 2 away from the axis of symmetry. So not -3, but -2 and -1. That's where these two numbers came from right here. And all you have to do is find out these two values, y values, by throwing it into the equation. And that's what we did here. So we threw each one of these into x and solved for y. And we found out these dots were placed here. This is 1/2 in between 0 and 1. And then the mirror image of that is 1 away here. The mirror image of this dot is 2 away over here. Okay. So our domain was open-ended -infinity, open-ended positive infinity. The range was definitely 0. That's why there's a bar there. And then -infinity down, all the way down, because it opens downward. All right, last problem. Last problem. Okay, and let's work through this one. See how much you can do without me. Before I start, I'm going to give myself about 3 or 4 minutes to work this. Notice you've got more points here. Now, and also all the training wheels have been taken off here. They haven't given you any of the formulas or the values or anything that you need. This is just like, okay, here's the, if I were to give this to you before you started today, your jaw probably would have dropped. Okay. But now that you know enough about the material, you can throw in formulas like that. You know, the vertex is h minus h comma k. You know, the axis of symmetry is x equals h. You know whether this opens up or down. The a was 3, right? How do we know that a is 3? Well, if you go back up here to the original equation, remember that's plus k, okay? Going back to the formula, I'll prove that to you. Let me go back to that sheet. Look at that. See, there it is. It's plus k, okay? So now a is 3, so that means it opens upward. H, now this one's tricky again. This is minus -4, so it's minus, h is -4, okay? What's k? K is plus -5. See that? They're trying to trick you, okay? So this is a minus there, so that's sticky. That stays with it, so it's -5 for the k there, okay? So there's your vertex. I'm going to go ahead and draw that on the graph. 1, 2, 3, 4. 1, 2, 3, 4, 5. There's my vertex, and I bet you your axis of symmetry is going to be this way, okay? So that means my axis of symmetry is going to be x equals -4 this way, okay? Now, we've got majority of what we need to know here. We know it opens upward, so it's going to look like this, all right? So now we're going to throw in a smart way, we're going to throw in some values here. We don't have to throw in this value. We already know what that is because of the vertex form. We know the vertex. The rest of it is what we're going to have to work on. So I'm going to go this way, going towards 0, and then I'll go 4 numbers this way, and then you can put 4 numbers this way and make that graph look really nice, okay? The more points you have, the nicer the graph's going to look. So I'm going to put -3, -2, -1, and 0. Let's start with 0 into the equation. The equation was, I'm going to put it down here so we can see it. Y equals 3x plus 4 squared minus 5. So we're going to put 0 in for here. And what is this? 4 squared 16 times 3 is 30 plus 16 times 3 is 30 plus 18, 48 minus 5 is 43. Double check me, make sure I'm right on that. That's, wait a minute, that's huge. Okay, we can't graph that. So that's off the chart, right? So let's go to -1 here. Let's see. So we've got 4 minus 1 is 3. 3 squared is 9. 9 times 3 is 27. 27 minus 5 is 22. And that's off the chart too. We can't use that. So, okay. All right, let's go to this. Let's do -2. That's 4 minus 2 is 2 squared. That's 4. 4 times 3 is 12. 12 minus 5 is 7. All right. So that's on the chart here. So we've got, let's go to the next one. Let me double check something here. Yeah, we're good. Okay. And then the last one, if you plug it in, it turns out to be -2. If you do all the math on that. So let's go through and figure out where these are. So we got -3, 1, 2, 3, and then -2, 1, 2 right here. And we've got -2, 1, 2, and then up 7, 1, 2, 3, 4, 5, 6, 7, all the way all up there. So now we're going to draw our mirror images. This is 1 away from the axis of symmetry. Then we have 2 away from the axis of symmetry here. And then we're going to, you see now why any other numbers would be way off the chart, because it goes so tall here. It's so thin. Okay. All right. So now we're at 40 minutes. So I'm just going to wrap this up. Today's been a good day, guys. Y'all stay safe, stay hunkered down in your homes, and take care of your family, and stay healthy and well. I'll see you as soon as we get back to classes. All right. Just high five me in the hall when you see me. Okay. Goodbye.